Hello, everybody. Welcome to day 2 of our Unit 1 lessons. Today we're going to talk about segment addition. You can find these notes that I'm going to be covering on our OMHS page in the Unit 1 Day 2 folder. And the key for it will also be available there, as well as this recording. Okay. So, here we go. Okay, so when we're talking about measuring segments, what we're talking about is the distance between 2 points, those points being A and B, and the distance between them is also called the length. So I can say that the length of AB is the same as the distance between point A and point B. And you're going to see that written as just AB with no segment. So remember, the segment symbol means the length of the segment AB, but without that segment symbol, and you just see it AB, that's talking about the distance. It's just the different ways that you're going to see it written. If you have two segments that are congruent, that means that their lengths are equal. So if the length of AB is equal as the length of CD, then I'm going to say that those segments are congruent. To write that with symbols, I could say that segment AB is congruent to segment CB. This equal sign with a squiggly on the top means congruent. So I can say that their lengths are equal or that the segments are congruent. And we're really going to be covering a lot of segment addition today. Segment addition says if you have two small segments and you put them together, then you'll have one larger segment. So if I say that I have a small segment AB and I have another small segment BC, and I add them together or I put them right next to each other, then they're going to make one bigger segment AC. Okay. So here's AB right here, the segment, and then here's segment BC. And when I put them together so that they're end to end, making one larger segment, that new segment is segment AC because we name segments by its endpoints. You can almost think of that point B as canceling out, almost. Okay. So in this diagram, I have a segment PR, and that's made up of PQ and QR. In number 1, it says that if PQ equals 9, let me go ahead and put a 9 right here, and QR equals 28, find the length of PR. Well, segment addition says if you have one small segment and you add it to another small segment, you're going to end up with the larger segment. So I can say that PQ plus QR equals PR. Well, the length of PQ is 9 and the length of QR is 28. So when I add the 9 and that 28 together, I get 37. So the length of the whole segment is 37. Let's see. Now we're going to change it a little bit, and we are going to say that what if happens if QR is 17? I already wrote on that picture. I'm going to redraw it over here just so we can write on it again. Same segment, just want to write on it. QR. All right, if QR is 17 and PR is 21, PR is the whole thing. Find PQ. Okay, well, we're still using segment addition. The small piece, which we don't have a value for, you have choices here. You can make it an X, you could keep it question mark. I'm going to keep it PQ. Okay, so I'm just going to say, all right, well, PQ plus QR, well, that's 17, equals PR, that's the whole thing. And now I just need to solve for PQ. What can I add to 17 to get 21? Or you could use your algebra and subtract 17 from both sides. So we know now that PQ equals 4. This will also work with some algebra. It says if EG equals 71. Oh, EG is the length of that whole thing. I like to put that in my picture. There you go. The whole thing is 71. Find the value of X. Well, I know that the small segment EF plus the other small segment FG equals the larger segment. That large segment we name by the endpoints EG. And now I'm going to substitute what I know. EF is 8x minus 17. FG is 5x plus 3. And they told me that EG was 71. Now all we have to do is solve for X. I like to combine my like terms. So 8x and 5x gives me 13x. Negative 17 minus plus 3. Plus 3, minus 3. That's silly me. That should be a minus 3. Let me fix that. There we go. Negative 17 minus 3 is negative 20. And now I'm going to add 20 to both sides. And I'll divide both sides by 13. So x equals 7. To check my answer, I could come up here and plug that in. 8 times 7 minus 17. 5 times 7 minus 3. Evaluate both expressions and add them together. You'll get 71. If you don't get 71, that means you made a mistake somewhere. In number 4, it says if TV equals 14x minus 8. Here it is. TV 14x minus 8. Go ahead and set this one up. How would you set this up? Segment addition tells us that TU plus UV equals TV. So when you set this up, you should have 9x plus 2 plus 5 equals 14x minus 8. Now combine your like terms and solve for x. Do that now. So you should have gotten x equals 3. That's a really good answer for x. And now we just need to make sure that we actually answer the question. It says find TU. So we're going to take that x and plug it in for TU. TU is represented by 9x plus 2. So for the x, I'm going to replace it with the 3. 9 times 3 is 27, plus 2 is 29. So our final answer is 29. TU is equal to 29. All right, on this page, we have some more examples with segment addition and algebra. Number 5 says JL equals 5x plus 2. So I'm going to go ahead and label JL as 5x plus 2. Let's set up our equation. Well, I know that JK plus KL equals JL. JK is 27. KL is 3x minus 1. And JL is 5x plus 2. Let's solve for x here, and then we'll take that x and substitute it to figure out the entire length of JL. Go ahead and try that now. So when you solved for x, you should have gotten 12. And then when you plug that 12 in for JL, you get 5 times 12 plus 2. So our final answer, JL is equal to 62. Number 6, it says that CE is 7x plus 4, and all we need to do is find the value of x. Go ahead and try this one. So you should have gotten x equals 5. If you did not get x equals 5, double check how you set up your equation. Make sure you combined your like terms correctly, and just make sure you added and subtracted correctly. Sometimes students do the hard part correctly, and then they make a silly mistake in their adding and subtracting. So if you didn't get x equals 5, go back through mine line by line and see if you can find your mistake. If you can't find your mistake, send me an email with a picture of your work, and I'll help you find it. If you got x equals 5, good job. number 7, we're going to solve for x, and then we're going to find each individual piece here. So we're just going to take that x and plug it in for each piece at the end. Let's label what they tell us. Sk is 13x minus 5. Ky is 2x plus 9. And sy, oh, that's the whole thing, is 36 minus x. Now, I like to set up that segment addition, sk plus ky equals sy. If you are confident enough to start without writing that, and you just want to go straight to the 13x minus 5 plus 2x plus 9 equals 36 minus x. If you want to jump straight to that step, I am okay with that. Just be careful. And if you do make a mistake at any point, you might want to just review that step that you skipped just in case. But if you're confident going to this step with the numbers and the variables, be my guest. Let's combine our like terms. 13x and 2x gives us 15x. Negative 5 plus 9 gives us a positive 4. I like to get all my x's to one side, so I'm going to go ahead and add an x to both sides. So 15x plus x is 16x, leaving me with just 36 on the right. I'm going to subtract 4 from both sides. And if you need to show more work on your scrap paper, you are welcome to do that. Divide both sides by 16. We get x equals 2. Wonderful. So I'm going to go ahead and put a 2 over here. Now all I need to do is plug that 2 into each of the expressions to find the length of each segment. So for sk, that'll be 13 times 2 minus 5. You're welcome to use a calculator for this. We get 21. For ky, 2 times 2 plus 9, we get 13. And sy, now you have some choices here for sy. You can plug it in, 36 minus 2, that's fine, you get 34. Your other option is you know that sk and ky added together will give you sy. So I could have just added the 21 and the 13 to get my 34. Both ways work. Okay. Let's talk about midpoint. Okay, midpoint is our attendance word today. So make sure that you write down that word midpoint. Capitalization doesn't matter, but spelling does. So make sure you spell midpoint correctly on your attendance quiz. Midpoint. So let's talk about what a midpoint is. The midpoint of a segment is a point that divides the segment into two congruent segments. So let's write that in. The midpoint of a segment is a point that divides a segment into two congruent segments. A line, a ray, or a segment that intersects a segment at its midpoint is said to be a bisector, or to bisect the segment. So it is said to bisect the segment and is called the segment bisector. In my diagram in this picture over here, B is the midpoint of the segment AC. And line L, I'll make it a fancy scripty L, line L is a segment bisector of segment AC. So midpoint, when I say the word midpoint, I hear point in the middle. So when you hear midpoint, it's the point in the middle. Okay, if I cut something exactly in the middle, that means that both pieces on either side have to be the same. Otherwise, it wasn't in the middle, right? Like if I have, let's say I have like a piece of licorice, and I tell my children that they can each have half. Well, if I cut it here, my son won't be too thrilled to get this piece when my daughter gets this piece, right? To make it fair and to say that I'm cutting it in the middle, I'm going to cut it so that this side is congruent to this side. And remember, we show congruence with these little tick marks. So these little tick marks mean that those two pieces are exactly the same size. That's what makes this point in the middle. If that wasn't the case, then this point wouldn't be in the middle. Bisector, when you hear the word bisector, okay, we know that bi means two, and sector is sections. So in geometry, when we talk about a bisector, not only are they two sections, but they're two congruent sections. So line L is a segment bisector because if I were to take a pair of scissors and cut along line L, I would be cutting my segment into two congruent pieces or two congruent sections. So midpoint is point in the middle, and anything that cuts that segment at that point is called a segment bisector. So in number 8, it says that Q is the midpoint of PR. The key word here is midpoint. Midpoint means point in the middle. So Q is exactly in the middle, which means that PQ has to be exactly the same length as QR. That's the definition of midpoint, the point in the middle making two congruent pieces. So knowing that Q is the midpoint, I can say that PQ is equal to QR. Now I can substitute what I know. 7x minus 16 has to be the same or equal to 4x plus 2. Run out of space, I'm going to bring that over here so I can solve for x. I'm going to subtract 4 from both sides and add 16 to both sides. Now I can divide both sides by 3, and we know that x equals 6. And to double check that, I can plug 6 in here for x, make sure that I get the same number on both sides. Okay, try number 9. H is the midpoint of GI. Solve for x first, and then once you know what x is, substitute that in there for GH to find the length of GH. Try number 9 now. So we know that GH has to equal HI, which means that 5x plus 2 has to equal 9x minus 10. We solve for x and we get x equals 3. Taking that 3, we substitute into for GH, and we get the GH equals 17. If you wanted to just make sure and check, you could take that 3, 9, and plug it in for the x over here, 9x minus 10. 9 times 3 is 27, minus 10 is 17. They are both 17, so that makes sense. Since H is exactly in the middle, GH has to equal HI. Okay. Number 10 is another practice problem here. R is the midpoint of QS. This time we're going to find the length of QS. So let's start by solving for x. Solve for x, and then we will do QS together. So solve for x now. All right, so x equals 11. So what I'm going to do is I'm going to come over here and I'm going to plug in 11 for each piece, each smaller segment. 2 times 11 plus 16, 5 times 11 minus 17. You can use a calculator to solve for those. You don't have to do this by hand if you don't want to. But these each equal 38, which makes sense. They have to be the same, right? Because that's what makes R the midpoint. So if QR is 38 and RS is 38, then the length of QS, this is where our segment addition is going to come in, right? Because the two small segments have to add up to the big segment. And since each segment's the same, we can say 38 plus 38. Or if you really wanted to, you could do 38 times 2, same thing. We get 76. So QS is 76. Now, number 11, it says if G is the midpoint of FH and FH equals 6y minus 2, Let's find y. If you're one of my honor students, you might want to pause now and try this on your own, but anyone is welcome to follow along with me right now. We're going to say that FH is 6y minus 2. Okay, midpoint is the key word here. G is the midpoint of FH, so FG and GH are congruent. Okay, so now we can set up our equation. So we know that FG is equal to GH, since that's a midpoint. So I know that 4x plus 3 has to equal 7x minus 12. Let's solve for x. I'm going to subtract 4x from both sides. Add a 12 to both sides. Divide by 3. All right, so x equals 5. So I'm going to come over here and do, okay, 4 times 5 plus 3. All right, this is 23. 7 times 5 minus 12. And that's 23 again. Now, I know that FH is 6y minus 2. We learned segment addition that says that FG plus GH equals FH. So 23 plus 23 equals 6y minus 2. Combine our like terms, add 2 to both sides, divide both sides by 6. So in this problem, we had to use what we knew about midpoint and segment addition to solve for x, which helped us solve for y. Okay, that's the end of the notes for today. Please don't forget to take the exit ticket. The exit ticket is available on OMHS for you. If you have any questions at all, you're welcome to join me in office hours or email me, and I'm happy to help. Have a great day, everybody.